Hi guys, this is QAShahin, and in this Let's Talk Theory and Practical video, I am going to talk about how I think you can build a good automation framework. It has to be said that it's actually very simple and very straightforward to build an automation framework that works. I think it's a bit tough to build an automation framework that works well. Let's get started. So what's the agenda of this video? Well, first of all, I actually want to take a second to talk about what a framework actually is. I think this will help to somewhat make things a little bit more clear as to the purpose of a framework instead of just jumping into automation framework. I will then try to talk to you about what I think are the desired capabilities of a good framework, and follow that up with some theory and some principle around frameworks themselves. As always, feel free to check out my blog post on this, and if you want, please feel free to contribute. So, what is a framework? The concept of a framework is to provide something which someone can extend. Now, that sounds very ambiguous. Let me explain. A framework is a set of guidelines, a foundation where you can build things on top. A framework isn't the finished product of something, it is simply the blueprint of something. So, for instance, say if I was building a house, the framework of the house would probably be the bars that hold up the walls, or the wood, or the type of joints you use, all of that sort of things that just hold a house up. But when you want to start, say, building walls, the actual physical walls, you need certain types of bricks. When you want to build the roof, the type of roof you want to build, so on. That is something that you add on. You sort of decide how you want to do it. When we talk about a framework in, say, automation, we sort of apply a similar concept. In other words, when a framework is given to you, more often than not, you have a selection of tools that are needed to be used for that framework. The language is already set, there's some level of configuration, there's some mechanics, so on. In other words, something is given to you which you can explore and expand, assuming it's something that actually you can do. So, let's consider this scenario. We have a manager who says that he'd like us to write some tests, and he asks the developer, what sort of tests do we have? The developer says, depends what kind of tests you want. We have some unit test, which gives us some coverage, but we don't really have any UI test. The manager says, okay, it's not very good. The manager was sort of expecting some UI tests. Then the developer says, okay, great, no problem. I will get back to you at some point next week. So what is actually happening in this conversation? In essence, the manager is asking the developer to write some tests. And the developer is simply saying that he would like to take some time to, first of all, understand what the tests are, what sort of tests they would need to write, instead of just writing tests. Why? Because you can't really write a test without thinking about things like technologies, without thinking things such as requirements, even considering, trying to feature proof the framework. All of these aspects are very important because they help you define the difference between a framework that works and a framework that works very well. Now, how can, say, the developer help himself to understand how a test framework should be? So let's just say, how could the developer, how could he or she understand what the framework should be? So some questions that the developer may ask themselves are, how many tests do we think we're going to end up writing? How many tests should be written? Should the developer take a step back instead of just writing the test? What sort of tests are we going to write? All of these questions, although they seem like very similar questions, they actually end up answering very different things. One will give us an understanding of, say, how many tests to write. Why is that important? Well, if you only end up with 10 tests, maybe you don't care about speed. If you end up with 1,000 tests, you probably really should consider how long it's going to take to run all of those tests. Certain things like that. So, when we talk about a framework, we need to understand the requirements of that framework. In simple terms, we need to understand what our problem is before we try to think of a solution. Many times, I've seen people just almost with a very knee-jerk reaction just decide, oh, I'm going to use the latest and greatest technologies, and they just jump into it. They get the latest technologies, whatever it happens to be in any given language, and they just let their passion go wild. And it's a really amazing place to be at, if I'm being honest. I've been there myself. It's great because you're sort of in this euphoria moment, you're in the zone, you're thinking about things, you're Googling things left, right, and center, upside down, whatever. And you end up building something, and when you see your first test pass, you're filled with a glorious amount of joy. But if you take that approach, if you think about it, you haven't actually done yourself any favors. If anything, you've sort of shot yourself because you haven't thought about things properly. You haven't thought about where your tests are going to run. You haven't thought about how things are going to be reported. You haven't thought about how often you may need to run your test. You might have thought about the language the tests are going to be written in, but did you consider other languages which might have been a better option? So when you end up asking yourself these sort of questions before you write a single line of code, you really should spend some time trying to answer these questions because they will help you think about things which will help to influence how you write your code. For instance, let's say that there is going to be some level of understanding that my test will need to run in different environments. When you start to write, say, a driver manager, you may start to think about an environment manager as part of that driver manager object. For instance, I want to be able to say something like run in a staging environment, or maybe run in a very testing environment. Maybe, dare you say, run in a very production environment. When we think about how our test should be reported, you may think about, okay, what is the best way for me to report my test? Is it important where my report goes? Are my report going to be exposed to the product owner? Is it just me and maybe my fellow developers who are going to be seeing this report? What sort of detail does the report need or is expected? That will influence what technologies you use, because not every technology provides the same sort of reporting. You may even have to write your own report handler. When we talk about how often the test should run, this naturally feeds into the world of CI, continuous integration, or continuous development. What sort of tools should I consider as compatible tools for my framework? Should I use something like Jenkins? Should I use something like TeamCity? Although a CI tool should be ignorant to your framework, it might influence your framework because if you use languages, say, such as Java or JavaScript, they would behave slightly differently based on the technologies you use for that given language against a given CI environment. When we talk about languages, some languages are actually faster than others. Now, this could very easily spiral into some sort of interesting discussion, but some would say JavaScript is faster than Java simply because JavaScript doesn't need to compile, and Java does. And that may influence the speed mechanics of your framework. So, when we talk about desired capabilities, these are some of the capabilities that I think probably are the most important. The first is speed. Now, when I say most important, I don't mean in order of top 5 or anything like that. They just have, in my head, slightly more precedence. There are other capabilities, but I think these are probably the most important that I see. So, speed. Why is speed important? Well, when you run your test, you want your test to run as quickly as possible. Why? Because you need to know if your product is still working, if the requirements are still working, has anything broken anywhere. If you run, say, a test and it takes 2 seconds, that's amazing. If you have two tests and they run sequentially, that's 4 seconds. Okay, 4 seconds is not too bad, it's still good. Let's just say you have 100 tests and they each take 2 seconds, that's 200 seconds. Let's say you have 1,000 tests and they each take 2 seconds. This can very quickly add up to potentially hours. The last thing you want is to push a single line of code and then have to wait 2 hours for your build to run. I've been in situations where you've written literally a single line of code and you need to push your code to production, but you cannot push simply because you need your build to pass. So what you do, you write a small test, you push your build, and the build has thousands of tests and every single one of them pass, and that's great, except the very last one which fails. You have basically waited, I don't know how long, but long enough to pull your hair out, of waiting for the build to run only to have the very last test to fail, which now means you have to rerun the build again, but you need to push in a fix for that last test. Speed is important. Being able to fail quickly is probably one of the most important things when you build a framework. You need to be able to fail fast. Next, maintenance. Why is maintenance important? Well, every time I push code, I assume that the person who's going to look at my code is a complete psychopath and knows my address. Why do I say that? Because I like to write code and push code that is clean and easy to understand. I have had to maintain other people's code and I have praised it when I've had instances where I've looked at someone's code and I went, this is a masterpiece, this is brilliant, it looks nice, it's so easy to understand, it's so easy to maintain. When I look at code which isn't as easy and as, let's just say, interesting, then that creates an issue because that means it's going to slow me down. I will need to take time to first of all understand it. I will need to take time to try and get a grasp of what's actually happening. Maintenance is important. If you write code in such a way from a framework perspective that makes your framework very confusing, you have no idea where the configuration files are coming from, you have no idea the structure of the folders, you have no idea where things are. This makes things difficult. Writing code that is maintainable is important, and there's a good chance your future selves will thank you if you write code that is easier to maintain from a framework perspective. Scalability. Now, why is scalability important? When you write your first test for your framework as a proof of concept, there's a good chance it's going to run, and there's a good chance it's going to pass, and there's a good chance it's going to put a really big smile on your face because you've just proved that your framework works, and that's amazing. And now let's say that your framework is amazing, it's working, you've handed it over to a group of people and they are doing an amazing task at trying to write all of these tests. And then a couple of months they come back and they said, hey, we've written 100 tests and they're great, but now we will probably need to write 100 more tests of exactly the same tests. So we're just going to duplicate the existing 100 tests and we want to run it against some other environment or some other language or some other locale, so on, but it's exactly the same test. If you haven't thought about scalability, there's a good chance there's going to be a lot of repetition in your code in order to satisfy that requirement. Why? Because you haven't thought about what would need to happen if your same tests need to be scalable. Scalable means expanding the test, growing the test. In other words, the test doesn't change. No line in the test changes. The test stays exactly as it is. The only thing that changes is maybe where the test runs, or how often the test runs, or at what times the test runs. You need to think about scalability. One possible way of thinking about scalability is through configuration. For instance, it should be really easy to say take a number of tests and run them in different parts of the world. For instance, in practical, what that might mean is run the same test on the same site in different languages. The test shouldn't have to change, but it should be such that by changing a simple parameter in a configuration file somewhere, that does it for you. Scalability is important. It needs to be strongly considered if there's a good chance that your test would need to provide support for not just the current version but multiple different versions of the same product. Extendability. Now, why is extendability important? Well, let's assume that the framework that was given to you, or the framework that you are creating, is very tightly coupled with some particular technologies. What that basically means is whoever ends up using the framework will be isolated to only using those technologies, and there is no way, no wiggle room in terms of trying to use a different set of technologies. Now, one may say, so what? So what if I end up using the same technology? I'm happy and I'm content. When you use a given technology, whether you like it or not, you will automatically inherit all the pros and cons of that technology. And over time, you may think about rethinking your solution. Now, rethinking your solution in the world of not being able to extend your framework is potentially a good or a bad thing. For instance, extendability is something that can be closely tied with making your framework very modular. Modular means being able to plug things in and plug things out. So for instance, let's just say we've used a technology like Cucumber. Cucumber is an amazing technology. It's a very great tool to help enforce BDD. But the way Cucumber works, you have to write feature files and then you have to write step definition for each step in a feature file. If you do that, then that means tomorrow if you decide to not use Cucumber at all, you just want to write tests, it's going to be very difficult to try and plug out Cucumber and just write tests, because you will have to do a lot of refactoring. If we take something, say, a little bit more closer, let's just say something like we used JUnit, and you want to switch out for JUnit with TestNG. Again, there will be refactoring involved, but the amount of refactoring, say, between JUnit versus TestNG or TestNG versus Cucumber is not the same. So being able to provide the option of extending a framework, i.e. plugging things in and plugging things out, is important. Something else to consider: if you tightly couple your framework to a technology which for whatever reason doesn't get any more updates, over time, because of the way technology moves, it will start to inherit security flaws. But because no updates are being done to it, then that means your framework is actually becoming more and more vulnerable. It's a polite way of saying your framework is sort of losing grip on the product. The last thing you want is to have a tool that tests your product which itself is faulty. Finally, error and debug. So this is something that not many people give consideration to, and it's sort of really personally I feel very unhappy when I see that error and debugging is not given any consideration. Error and debugging is probably one of the most important capabilities of a framework. Why? Well, let's just say we run a test and it failed. If it isn't clear what the failure is from that test, then what basically happens is that you're forcing whoever's looking at the test to start looking through your code. And in my head, that is the first hurdle where there's been a failure. You should be able to detect what the error is to, if not the exact issue, at least a best guess just by looking at the error. And the error of a test, yes, it comes from the assertions in the test itself, but if you handle your errors in such a way that when a test fails, you know exactly what the failure is, that saves you a lot of time. Debugging is something that takes an immense amount of time when something fails and you have no idea why. If one of your tests fails and you're in an instance where you absolutely don't know why it's failed, it's just failed, You have a test that's failed and it says something like expected A to be true, instead it's false, but it doesn't tell you what A is, it doesn't tell you where it got the false figure from, it's just giving you a line and that's it. Putting error to one side, debug is the other side, it's sort of the reverse of error. Being able to look through your code, the code you've written for your framework, is important. If when you're going through debugging something and you end up jumping from class to class, from page object to page object, and there isn't a logical way how things progress, it's sort of very spaghetti, then that's something that can make anyone's life very frustrating. Try to avoid having to over-engineer things, keep it as simple as possible. Finally, theory and principle. So, with everything said, what is the point of building a good framework? Why not just build a framework that we think is good enough? Why invest all of this time into building this? Maybe there is no need. Well, maybe you should ask yourself this question in a couple of months' time when you have to maintain a framework. Let's assume you just built the framework and you think it's good enough and you hand it over to a number of people that really need to rely on the foundations of that framework. If it doesn't work, if it's a bit faulty or a bit fragile, they will come back to you time and time again and they will ask you to make changes. They will find bugs in your framework and they will ask you to fix those. If their code or their test stops working or doesn't produce anything, and if they can prove it's not the test that is faulty, it's the framework itself, then although you are at no fault, not really, but your framework is contributing towards a problem and not a solution. On the other hand, if you take the time to build a framework that you feel should work, and even if it doesn't work, it will give any developer as easy of a journey as possible to try and find out what the issue is, then this will only help in favoring promoting your framework. Me personally, I've had the pleasure of working with frameworks that have been really easy to use and amazing, and I draw inspirations from those frameworks that I've used in my own YouTube videos. And I've also had the adventurous displeasure of working with frameworks which have been a bit interesting and fragile. It's not a comfortable place to be in. So what have we learned in this video? So this video was a slightly long video. It was a lot longer than I was expecting it to be, but I think it's important that we understand what a good framework is. It's really important that when you start building frameworks, when you start to go into a automation role and you're asked to build a framework, the biggest mistake you can do is jump into it straight away. But the biggest probably advantage that you could gain is just take the time to find out what sort of framework you actually want. Don't build anything before planning. Plan it, think about it, understand what is expected of the framework, who needs what, who should get what, and that will help you build a framework that's going to be sustainable, maintainable, easy to use, and maybe even fun to write test against. Thanks a lot for watching this video. I will see you in the next one.